Recording in progress.
Sweet. Okay. Properties of logs. All right. So let's review this. You guys remember when you multiply two powers of the same base, how do you combine the exponents? You add them. Good. So this one right below for 6106, I'll go red so it stands out, will be XA plus B. So for example, if I have 2 cubed times 2 to the 4, that would be 2 to the 7th power. Okay. What happens if you have two powers that are divided with the same base? How do you combine those exponents? You subtract. Good. So it'd be XB minus A. So for example, if I have 2 to the 4 power over 2 cubed, that's easy. It's 2 to the 1 power. Okay. Which makes sense because you have 16 divided by 8, which of course is 2, if you were to work it out. Yes, you do numerator minus denominator. Correct. Right. Yeah, top minus bottom. So we're going to investigate, and we'll use a calculator to kind of help us find some patterns for logs, because logs have very similar types of properties. And it's not going to be terribly obvious in the beginning, but through investigation, we'll determine what the properties for logs are. And they're very similar to the properties of exponents. All right. So let me position it like this. And you guys might want to get a calculator if you have one. If not, you can look up a partner or someone sitting next to you. All right, so Dropbox. Okay. So let's go through the notes here. Okay. If you have log 5 plus log 6, if I just type that in, and make sure you close the parentheses, very important. Otherwise, it'll log everything after. So log 5 close parentheses plus log 6. It's going to be some weird number. Okay, that's 1.477. Now, is there some sort of shortcut I could do to combine those two logs? What do you guys think?
6 minus 5.
Well, hold on a sec. What's the base if you don't see one? If you don't see, it's 10, right? So apparently this equals 1.477. Now, if you think about it, if I set this equal to 1.477, x is an equal 10 raised to that power, right? So let's take a step back, guys. Reggie and John, you guys focus, please. Thank you. So let's think about it. When I put this in the calculator, I got log. Sorry, when I add these to 1.477. So if I set log x, which is equal to log 5 plus log x 6, right? If I set that equal to 1.477, right? And if you guys remember, if you don't see a base, assume it's 10. It's common log, like you guys do with pH and chemistry class or bio class, right? How do you shift this exponential form? 10 gets risen to that power. If 10 is risen to the 1.4 power, what do you think 10, or sorry, what do you think this number would be roughly? Like, would it be more than 10 or less than 10? So it's definitely more than 10. And it looks like it's pretty close to 30. Okay, so you got 29.9 something, right, Alexandra?
5.6.
Exactly, yes. What's going to happen is that when you have a plus between two logs, you're going to multiply the two numbers. We're going to see this a few more times. So instead of writing 1.477, that's kind of weird. It's not a nice number. I'm going to write it like this instead. I'm going to write as log 30. Okay. So if I do this a few more times, let's say I do log 5 plus log 2. I get 1. Well, what's log 10? That's 1. Because 10 to the 1 power is 10. So I suspect this will be log 25. This will be log 1000. This will be log 99. And in essence, this will be log of A times B. So for example, if I were to do like log 10 plus log 100, because that's going to come out pretty clean. Plus log 100. So if you think about it, that's 3 because that's 1. And that's 2. Of course, 1 plus 2 is 3, right? But also, if I combine these two, 10 times 100 is 1,000. If I log 1,000, what does 10 get risen to get you 1,000? 10 multiplied how many times gets you 1,000? 10, 10, 10, 3 times, right? 10 times 10 is 100, times 10 is 1,000. So this is the property we're seeing, is that when you have 2 logs being added with the same base, you can multiply the 2 inputs, a times b. So it's very similar to this property. And in fact, actually, you could derive it. I'm not sure if we'll derive it today. I'll have to look at the notes. I should have actually looked at it in advance. I kind of wing it, as you guys tell sometimes. But anyway, where we know this, right? This is a true statement. It's very similar. It's very similar. What about the minus? What do you think is going to happen there? We're going to divide, yes. So what's going to happen here if you work this out? I'll do one of these on the calculator, and the rest will just kind of just tell you what the answers are. You could, 100%, yes. Yeah, you could do 20 over 5, which is still 4. But some of the other ones, yeah, exactly. 5 halves or 17 ninths, right, right. If I do this, 5, if I do log 4, it's the same exact thing. So this will be, we'll switch colors for a bit of contrast. So this will be log 4, log 10, log 5 halves, log 17 ninths. Oh boy. Log of, no, I wouldn't assume it is. That's not going to be. So in essence, it's going to equal log of b over a. It's very similar to this scenario, right? Very, very similar to that property of exponents. So these are 2 properties. Like these are going to be pretty important to help you condense logs when you have like a equation with a bunch of logs in it and you have to condense them. This can be helpful for anyone doing the ACT in April. They sometimes do test this concept. SAT, they don't. Not on the SAT. Never seen it before. Anyone doing the pre-ACT or the practice SAT for sophomores or doing it? No, you guys are juniors. But they're doing it here, I think, next month by some test prep company. You might see this concept. So, okay, let's keep moving. In case you guys are curious, the ACT is changing. It's becoming a shorter test. It's and they got rid of the science, or it's optional. So
Wow. It's optional.
that means that you don't have to do the science section if you don't want to. Yeah, I mean, they average scores for the 3 sections that you took. So
then at this point, like, if science is optional, and what's the difference between the ACT and the SAT?
not much really. And it's also going digital and it's getting shorter, so they're roughly about the same time. I think the one big difference is that the math is a little more advanced on the ACT. Like they actually do cover logarithms and some pre-cal type topics. The reading passes are longer, I think. And just the types of reading and writing questions, I think, are a little different. But yeah, I think they're going to be pretty identical for the most part. Oh, the SAT is adaptive. That's a big difference,
Yeah.
right? It's adaptive, whereas I mean, if you do well, you didn't get that. Do well, because you want to get a good grammar score too. They don't test you on that. Don't worry. I'm teasing you. Don't worry about it. Nope. Do well. Yeah. I don't know. I don't really care. Okay. Well, they don't test it on the SAT though. I make the same mistake. It's really more punctuation and sort of agreement, stuff like that.
That's so bad.
Okay, anyway, so these are the 2 properties we're looking at. Log A plus log B is log of A times B. Log B minus log A is log B over A. So we call this the product property. We call this the quotient property. So this is going to be, and by the way, the bases could change. So for example, if I have log base 360, that'd be log base 36 plus log base 3 of 10, or log base 3 of 20. So let's take a second and think about this, what we just did. I found two numbers that multiply to 60, 6 and 10, right? What multiplies to 3 to get 60? Fine. So these are two statements.
Sorry, is this 6 in the log 3? Like that's the
Yeah.
exponent?
Yeah, no, that's the subscript.
No. I mean, like in the first one, the one, not the one that you wrote.
This one?
Yeah.
It's not an exponent at all.
Okay.
That's the input. It's the input for the log. I'm trying to understand why do I have the extra equal sign in the middle? I'm a little confused with how this is working. Just give me a sec here. I'm a little perplexed with what. Oh, I see what's happening. I get it. Okay. Okay. I see how this works. So you want to figure out what. So this is going to equal all the stuff in the row right next to it. Got it. Okay. So if you have a minus, what would you divide 120 by to get to 60? 120 divided by what number gets you 60? 2. And then what number do you divide by 240? So what 240 divided by what number gets you 60? Close. 4, right? Okay, so each of these, yeah, now I understand what's happening here. I was a little confused. So each of these statements are all equivalent. Every single one's equivalent. Okay. So 6 times 10, 60, 3 times 20, 60, 120 divided by 2, 60, 240 divided by 4, 60. Okay.
Yeah.
All right, we're good? Okay. Hey, Luca, can you stop talking about random nonsense? Thanks. Appreciate it. Oh, okay. Yeah, keep looking focused. Thanks. All right. So next up, give me two numbers that multiply 36. Any two numbers. 6, great. So you log base 7. Actually, I'm really glad you guys brought that up because that leads us to our next property. So it'll be a nice segue to what we talk about in a few minutes. Give me two more numbers that multiply 36. 12 and 3. Perfect. Good. Okay. Give me two numbers that divide to 36.
Oh, 72 so far.
72 and 2. It's okay. John, you want to redeem yourself? Oh, so shoot 7, but what? So wait, base 7, my bad. Sorry. Base 7 of 12. Sorry, 72. Yes, can you give us another one, John? Good. Excellent. Wow. Some big numbers there. Okay. If you see 9 and 2 being added with logs, if you condense it, what does that become? Log base 6 of what? 18. So give me two numbers that multiply 18 besides 9 and 2. 3, 6. Love it. Log base 6 of 3 plus log base 6 of 6. Give me two numbers that divide 18. Switch colors here. What two numbers can divide 18? 36 and 2. Why do I keep doing 3? Here. Or 72 and 4. That's another option. Okay, Let's look at this one here. 75 minus 1.5, but they're logs, obviously, right? So we want to divide these two. It's a little tricky. Don't know what that would divide to. 50. Yeah, it's 50. Mhm. Yep. That's log base 25 of 50. Give me two of those that divide to 50.
550.
Oh, so you said 102? Perfect, 102. 102, sorry. I said it really fast. To 50. Two numbers that multiply to 50.
25. And
Perfect.
I'll do that. Math genius.
Do you want to do another one? Give me another one. That multiply to 50. 10 and 5, good. Yeah, you can see this becomes really cumbersome to write these over and over again. And these are 25 is a subscript, by the way. So log base 25 25 plus log base 25 2, or log base 25 10 plus log base 25 of 5. So those are all different options. Okay, last one here. We'll go purple. 160 minus 4. So this is division again. What does that divide to? 40. Good. Yes, 40. And this is common log, thank God. I don't have to do a subscript. Give me two numbers that multiply 40. 4 and 10 or 2 and 20? Sure. We'll go with both those. 4 and 10. And 80 and 2 we would divide. So okay, all good? Cool. Okay. So let's talk about this here. So when you have plus, you multiply. When you have minus, you divide. Also, another thing I need to mention as well. Remember we had this here, log base 6 of 36. Remember we said this earlier in your notes, just up above the page. If you think about it, what's log base 6 of 6? No, 6 to what power gets you 6?
2.
So 1 plus 1, which of course is 2. Is that what you meant? The final answer is 2? Okay, so final answer is 2, right? Well, here's the deal. This is also like saying 2 times log base 6 of 6. And a 2 could roll to the back and become 6 squared. So that's also another thing we could do as well, is that when you have the log of if you have a number kind of like this here, it's the same thing as saying this. You could do that. That could be a power. So we'll talk about that for parts C and D and E. But in this case, if you think about it, here I'm going to multiply. And here I'm going to divide. So that's going to be log base 1/2 of 8 minus log base 1/2 of 5. So you get that.
Purpose of this.
Yeah, I'm like you.
I don't know.
Like, it's just, I feel like it's just
No.
explaining something that.
Well, we are going to start looking at equations of all logs, like multiple logs, and you need to use this technique to condense them. And there will be some word problems that involve this. Yes, exactly. It's adding to that skill set. I will say when you do move on to calculus, you do have to know this property really well.
It's just like algebra, but now it's inside logs. It's
Correct.
algebra
Correct. Okay, that makes sense. How I did part A. Okay, part B, which I'm going to do over here because I ran out of space, is log base 2 of mn Part C.
Look, they have different logs.
Yeah, they have different things.
Oh, you're right. Ooh, look at you guys. You.
How if we just pretend that they have
So you can't do it. Can't do it. Done.
It's like if you're adding matrices.
It's kind of like that in a way. Yeah. Good catch. I should have seen that.
wait, how?
Different dimensions. This has different bases.
Um,
It's just saying it's analogous to it. I mean, it's a different. If it works for you, Alex, it works for me. Okay, for part C, however, you're gonna do this. Yeah, it can't be simplified because different bases. I should have seen that. Thank you for catching that. I know, right? Exactly. I'm fine. So guess you're fine too. All right. Anyway, you have this, right? So as I mentioned, oh, that's an X, not a K. My bad. Okay. So when you have a number or a letter out in front, you can actually roll to the back and become an exponent. Okay. So that's called the power property. So this right here, which I described, is called the power property. And then you can combine it like this. Log of K times M raised to the X power. Okay, let's check. Are the bases the same for part D? I remember that made a mistake earlier. They're the same, right? Now, the 1/2 can roll to the back, and the 2 can roll to the back to become this. So this is a proper reason called the power property. So just accept it. That's, I mean, we did see why it worked. Because remember I did this earlier again? I'll do it one more time. Remember we had this, right? And then that becomes 2 log base 6 is 6. And 36 is 6 squared. So that's why we can do that. We can move that 2 back. That's a property we're allowed to do.
no, it's not.
Hey guys, can you focus, please? Thank you. And if there's a plus in the middle, you can combine like this. By the way, do you guys remember what x and 1/2 is as a radical? You guys remember that? No? Yes? Okay. Well, that's a radical. Just so you know. Here, I'm gonna get a little creative here. Yeah, good.
That in its most simplified form,
Correct.
you couldn't like square the whole parenthesis.
You can if you want, but that makes it bigger. I don't know if I would do that.
Plus x
It-
plus 1.
It would be x squared plus 2x plus 1. Then you could distribute the root x, but I wouldn't do that. It just makes, you can. It's up to you. The bottom line is we want to get down to 1 log. That's all that matters. Yeah. Right. Single logs.
Log. As long as there's like when we're condensing logs, you just have to make it down to 1 log, but it doesn't.
Right. But same base.
Okay.
The mistake I made part B. Now for E, I'm gonna skip a couple steps here. Mhm.
Then you have to condense it to the 2 different types of bases.
If it's two,
So like let's say like half the problem is log base 2 and then the other half is log base 3.
you just do them individually. Yeah.
And you do the
right.
log base 2 is 1 and the
Right. Right.
answer will be log 2 plus log.
The other one, right? Correct. Okay, let's look at E. E is a little crazy. 3 rolls to the back, R cubed. You have 2. You have how many positive logs? I have 3 positive logs, right? 3 positive logs. Only 1's negative. Only 1 goes in the bottom. Okay, only 1 goes in the bottom, but 3 go up top because they have positive logs. So all the positive logs go up top. All negative logs go in the bottom. Let me write this down so you guys can make sense of this. All positive logs go up top, and all negative logs go on the bottom. That's x to the half. When you have x to the half, it's root x. Okay. F can't be simplified. Just is what it is.
You don't multiply the.
No, because you don't have a log next to 23. So you just leave it alone. Yeah.
Dumb question. but
Good.
when it
What's up?
comes to-
No, yeah, this
When it comes
yeah, once you get down
If you
the
ever
line,
have like a log,
It's hard on
on,
number,
like, a log on top,
number
like
4.
on the, like the numerators log and then the denominators log.
You can't do anything about it. You leave it alone. Can't do anything about it. No. That's a separate rule called change the base. We're not there yet, but we can't.
Top of the, like the numerators, like log.
Right, no, I know what you mean. If you have something like this here, if you have like log of 6 over log 2, yeah, you leave it alone.
You
Right.
have, like log 6, and then you have, I don't know, like R to the third or something. I don't know.
Leave it alone.
And then you have log 6 as well.
You leave it alone.
Wait,
You can simplify, like, wait, can I write it?
Like you see,
Like-
you mean something like this here?
No, no, no. I mean, like.
Sure.
it's
Why don't you try
like-
the board? Good.
where did the
It's like,
cube come from?
it's like log
Oh, the 3 next to the log
6.
because you have log 3 log r.
Oh,
Or
yeah.
log 6. You couldn't just like.
Well,
copy
you
this out.
well no well, first of all you need a number here. You need a number there.
Chill.
You don't have a number there.
What if you just have like R? Then would it just simplify it?
No, you can't do anything about that because you're dividing 2 logs.
So, okay, because this is technically still part of.
It's
the log. Okay.
so
okay,
so
sorry.
so the answer to your question. Okay, first of all, can I clear the screen? Okay,
Oh,
so to answer your question, you have like log base 6 of like say 10, or log base 6 of say like 4, right? Okay, here's the thing: it's PEMDAS.
Okay. So the 4 is.
The
still-
numerator is its own parentheses. The denominator is its own parentheses. You got to work those out separately.
But you would never.
Then
have,
divide.
like, a log and then something else after it.
No. Nope.
can you divide those?
No, well, I mean, after you work each one individually, you could divide them.
Number.
Right. Okay, so let's just let's close the loop here on this stuff, and then I think you guys should. So this actually proves these properties. So we're gonna do the proof. So yes, we are doing the proofs. No, not 2 column proofs. No, don't worry. Don't worry. Okay. Okay, let's assume a equals m to the x. Let's assume b equals m to the y. So you have that, right? Now, if you think about it, how do I combine those 2 exponents? Correct. And what happens when the base of the log and the base of exponent are the same? They pretty much cancel. No, you're confusing what we just talked about earlier. No, I'm just saying when you do the log,
What's that?
the log of a okay, you guys remember we had this log base. If I had like something like this here,
Yeah.
like it's like these canceled. They don't technically cancel, but it's kind of like they do. And then you just got 3 as your answer.
But I don't like mess this up. Sure.
No.
If we think about it.
Well, no, not really. It's just pad form, that's all. So what we noticed is that we get x plus y. Okay, we work this out. Well, remember, if we rewrite this in log form, this becomes log base m of a equals x. And this becomes log base m of b equals y. Okay, I need you guys to focus because this part gets a little tricky. So,
It's up here.
okay, a equals m to the x. So if you rewrite this, which we talked before, log base m of a equals x, log base m of b equals y. If you have x plus y here, I just replace the x and y with the logs, and you get this here. I'm not sure yet. Actually, I want to do on this Friday if that's okay. I'm kidding. I don't know. I think actually we're aiming to do it March 7th. So I think the end of next week, I think. So I think. Okay, so guys, let's. It is soon, I know.
It's a great young mind. Yeah. It's terrible. How's that terrible? It's too hard.
We all have time.
Terrible.
Let's see how it goes. Okay. You guys, quiet please, thank you. Okay, I wanna make sure. I know it's the afternoon, we're getting a little swirly here, but. Oh, no, okay. No, we're okay. You guys are okay, too, okay.
Squirrely.
So let's, okay,
Swirly.
swirly.
Forgot.
Okay, A equals M to the X again. B equals M to Y. We made those assumptions. We said let that happen, okay? Now. If I replace A and B with those expressions, M to the X and M to the Y. Remember, you multiply two powers of the same base, you add the exponents, we know this, M to the X plus Y. Also, if you rewrite A as a log, that's log base N of A equals X, log base B of N equals Y. If I replace X, Y with their log, guys, please, thank you. If I replace X, Y with the log expressions, I get this. So instead of X plus Y, I have log base N of A plus log base N of B, and that equals log base N of AB. So let's try the next one. If I divide the two, wouldn't it be M to the X over M to the Y? How do you combine those exponents, guys? How do we combine when we have two powers of the same base? Hi. What do we do to the exponents? Good, subtract. And that just comes X minus Y. So if I approach it in the same manner, I'm gonna move the screen a little bit here. Let's erase this junk. And let's move this back up. Here we go. It's a little hard, I know. Okay, you guys, okay, this is the part where I think you guys are getting lost. And again, it's the afternoon, I get it. But A equals M to the X. How do I write this as a log equation? Log base of what? M of A, good, equals. Remember, the whole purpose of logs is isolating exponents. Same thing here. Log base M of B equals what? Y. Now, what does X equal? Let me get a highlighter. This will, I think, will help you guys. I should be highlighting this stuff here. Okay. Those are the same, right? Let's use green. Those are the same, right? So if I simply replace X with its log and Y with its log, I will get the quotient property derives. So this right here, log base M of A over B equals log base M of A minus log base M of B. The last one's a power property. So if you have A cubed, that's like saying M to the X raised to the third power. That becomes, you're doing this 3 times actually. Because you're cubing it. So it becomes this log base M of M to the X. And it's repeated 2 more times. So you get 3 times log base M of M to the X power.
What happens something like after the log?
What do you mean?
Log base M A B, and then after I have like +7 or something. Do I just do all of this and then you add the 7 after like 10 bells?
Right, okay, exactly, correct, right. Yes, you are gonna follow order of operations, and logs are actually the same hierarchy as exponents. Okay, okay, I think I've exhausted you guys for one day. So we'll stop there. Homework will be 1, 2, 3, and 6, 120, 6, 133. We still also have the other stuff to do as well. So I think what we'll do is we'll make kind of Wednesday kind of like a catch-up day in a way. So we'll make sure we review homework first and make sure you guys are comfortable with the homework. The homework is going to be 1, 2, 3, 6, 120, 6, 133. We still got another 17 minutes. So you guys can actually get a put a good dent in the homework. Okay. And oh, okay, let's not do 6, 121 or 4 or 6, 1, 3. I think that's too much. That's too much. That's too much, guys. So we're just gonna do 1, 2, 3, 6, 129, 6, 133. Okay. The rest we'll do in class. We'll do a catch-up day on Wednesday. Okay. And then the two right below them, the 6, 129, 6, 133. For you, I didn't.